Shall we start?
Yes.
Good evening, everyone, and welcome to the third day of the 6-day ATAL-sponsored online faculty development program in Cloud and Edge Computing, Research and Industry Perspectives, organized by the Department of Computer Science and Engineering, Adi Shankara Institute of Engineering and Technology. The first session of the day focuses on an important and contemporary topic, cloud in research and industry, highlighting how cloud technologies are shaping modern research practices and driving innovation across industries. It is my privilege to introduce our first resource person for the day, Mr. Jacob Thomas, who serves as the delivery manager at Tata Consultancy Services, Kochi. Sir brings with him strong industry experience and practical exposure to enterprise-level cloud solutions. His insights into the role of cloud computing in both research and industrial environments will be highly valuable to all participants. Sir, we are honored to have you with us today. I kindly invite you to take over the session and share your expertise on cloud in research and industry. Thank you, and over to you, sir.
Parvati, Shani, have you checked Jacob sir joined? Hello. Hello. Am I audible? Shani?
Ma'am, you are
Yes,
audible.
ma'am. You are audible.
Okay. Have you checked whether Jacob sir joined?
No, ma'am, he is not joined actually.
Okay. I shall call. I have informed TCS Raji. So let us wait for some time. Also wait for all the participants to join. Please ask the participants to join the WhatsApp group. Raju has responded. Let us wait for some more minutes.
Yeah, hello team.
Sir, good evening, sir.
Yeah, good evening, ma'am.
Yes. Parvati, please introduce him.
Yes, ma'am. Good evening, dear participants. We are about to start this first session of the day 3. Hello. Hello.
Admins, could you please make the speaker as a co-host and mute the remaining or?
Ms. Jayanti N, can you mute your mic? Ms. Jayanti N, can you please mute your mic?
Good evening, dear participants. We are starting with the first session of the day. The first session today focuses on an important and contemporary topic, which is cloud in research and industry, highlighting how cloud technologies are shaping modern research practices and driving innovation across industries. It is my privilege to introduce our first resource person of the day, Mr. Jacob Thomas, who serves as the delivery manager at TCS Kochi. He brings with him strong industry experience and practical exposure to enterprise-level cloud solutions. His insights into the role of cloud computing in both research and industrial environments will be highly valuable to all participants. Sir, we are honored to have you with us today. I kindly invite you to take over the session and share your expertise on cloud in research and industry. Thank you, sir. Thank you, and over to you, sir.
Thank you so much, Parvati. Let me first of all apologize for being 10 minutes late because I was under the assumption that we'll be starting only by 7 o'clock, and extreme apologies for joining 10 minutes late. Just give me a minute. I'll be sharing my screen shortly.
No problem.
Okay. So before we start, I just wanted to understand that this, I believe, is a faculty development community that I have here, right? So do I have faculties from only Adi Shankara, or we have faculties from all other colleges?
So we have faculties from all over India, sir.
Oh, okay, really great to know. Thank you so much. Just give me a minute. I'll share my screen. Right. Let me know once you're able to see my screen.
Yes, sir, it's visible.
Okay. So thank you so much again for inviting me to this event, especially the faculty development program of Adi Shankara Institute. And special thanks to Adi Shankara Institute for hosting this, as well as continuing the relationship with Data Consultancy Service, where I'm working. So to start with, basically, I understand this entire session of programs for the faculty is mostly to sensitize them about the cloud computing aspect of it, not just restricting to cloud, but also to the edge computing, what it is, how it is, and what is the different areas which are getting impacted by its evolution. Now, let me tell about a bit of history. Like when we initially had servers, or the concept of servers, it was mostly on premise in nature. There were a lot of LAN and cables that were laid down, and starting right from the mainframes, wherein we did not have much of internet during that time. It was mostly to do with a one fused system, if you ask me, wherein there will be a DB2 database, and there will be a front end which doesn't have much of a UI. It will all be the black and white screen. So those were the initial 80s IT, if you ask me. Now, from there, there was this drastic explosion, which kind of took the application into a different level. Especially, as I said earlier, when the internet came through, we were able to transfer data alone in packets, and we were mostly able to do that, and it did not have fused servers or fused database, but we were able to keep separate. That's database is separate, front end is separate. There will be the middleware layer or the API layers that came across. And fast forwarding into 2024, we are close to around 700 billion revenue, and 700 billion in market cap, if you ask me, in terms of the cloud revenue that we are talking about. And in 2025 alone, this has grown by 400 billion. Now you can imagine the compounded annual growth rate, or CAGR, as we talk about. So that is the market value or the scale in which it is growing in industry. Now every organization is behind the cloud because there is application. And every company is not just a organization, but it's also transformed into a learning organization. Now, when we say learning organization, it is mostly to do with data that they have in place, historical data, analytics. If you look at any business, be it a bank, in our traditional banking system, it was more of a transactional place where they used to have ledgers, and then transactions was recorded in ledgers, and once we had one, just give me a minute. Yeah. So once we had our databases, these databases were later evolved into a specialized Oracle or other systems. So now, sorry, I'll just share my screen again. Yeah. So once we had this particular databases for the banks, this also evolved later into specialized bank-friendly, like Oracle or the Finnacles of the place. And at a later stage, once we had this, the business also transformed. That is, different business models were evolved. They also started selling insurance, and at a later stage, it also went up to the UPI level. Now, if you ask me, in a traditional banking system, or how does a typical ATM works? Once you take the money from the ATM, this particular ATM has a ledger on its own, and immediately after you take the money out of the ATM, if you check your balance, I'm sure it would not have been synchronized, because once you get an SMS, this particular ATM has to communicate with the servers, and this particular servers will be having a copy of your daily transaction, and this will be written only to the master data of your bank servers or bank central servers, as we call it, by the end of the day. So we are still dependent on this set of processes. So this processes also has evolved in its across a span of time, because when we speak about, I'm not sure if you have heard about the ETL systems, the extraction, transformation, and loading. When we say that is mostly to do with the database taking, we make the changes in the database based on the day-to-day activity, and then we upload it, or we kind of replace the this thing. So now, what is the role of cloud computing in all this? Now it has all happened, or any tool that you talk about, be it the data stage or the Informatica, or in the new AI era also, all the tools need a place where it can scale up, and this scaling up was made possible with the help of the cloud computing. So that is where the cost reduction in terms of, like, we can take it as a service. I remember when TCS used to go to this small and medium scale enterprises, like, to give an example, be it the Kontodi Travels, if you know, or the Melam Masalas, which are all small and medium scale enterprises. We were able to sell them what is called as a ERP, the Enterprise Resource Planning tools, at a very just medium rate of hardly like 50,000 or 1 lakh rupees rent on a monthly basis. So they did not have to do anything, but all we could give them is a instance of the cloud, the hosted application on the cloud, and we will be just hosting it in our EC2 bucket or so, and we will be able to give it to 5 or 6 other vendors, and they will be able to, and we just need to make sure that we have separate database instance, but the same application is being utilized. So that is the benefit that this particular cloud has brought in. And if you ask me, it is a very explosive, or the technological explosion is what has happened with the help of evolution of cloud. Now coming to the performance, we have seen a drastic increase in performance. We use the term latency just to make sure that there is no delay, because delay in business, especially if we are talking about a business like banking or in a share trading, wherein even the seconds matters. So in a business where latency is really a matter, then cloud has really helped us give a lot of RAM space. I'm not just talking about the storage space, but we are able to scale up and we are able to process information at a needed space, and that too whenever required. I remember when we were working for a project which required its quarterly results to be published in a website, we would be bombarded with 2.2 million hits to the servers, and after the initial, there will be a lot of chatbot attacks, there will be a lot of bots that come from the media, because these medias and all need to crawl through the website and get as much information as possible so that it can be reported first. Because in a world where news has to come fast, or it has to be posted in social media, then it has to be crawled, and these days this crawling is also done by bots. And so in a drastic 2.2 million hits, after it reaches the caching or the direct server hits, we were able to scale it up, and the delay in instance is something that we couldn't afford. So the crux of the matter, what I'm saying is, we were able to scale based on the need, and we could easily scale it up to 2.2 or up to 5 million based on the requirement. On a normal day, it would be hardly 1 lakh people who will be visiting that site. So similarly, now coming to the last part of the cloud revolution, it has also helped us innovate faster in terms of process, because as I said earlier, right from the ledger system, because if you look at any organization, be it any NGO or any bank, you will find something like the trial balance sheet, P&L. So all this ledger system, this consolidation, we were able to make it change through a single source of truth. Now that is where innovation plays a role. Now when it comes to cloud, we made the same thing accessible to all. Because if you ask me, in the 80s, in the 90s, or in any organization, the major problem that occurs is with respect to the communication, is with respect to the difference of data. I mean, even if it is in your organization, imagine like how it would have been 20 years back. You had to come to the college, you had to sign a ledger stating that, okay, you came in this time at this time. And what has it changed to? Now it has changed to either you swiping your card in a sensor, or you are putting your fingerprint, the biometric is tracking your record. So what happens is the administrator of the office get a report, and similarly that particular process has been automated. So similarly, there is a lot of innovation also which cloud computing has been has empowered. All right. Right. So let me not go into definitions, because I understand all of your faculties, and going into definitions is kind of very trivial. But then when it comes to cloud, I'm sure all of you know that in the industry, enterprise, mostly the market share is had by the AWS, the Amazon Web Services. Then we have the Microsoft Azure, which kind of comes at the second place. And I'm not talking about the traditional giants. Okay. If you ask me, the traditional giants like the Oracle, the SAP, and all, they are all traditional people, but their focus is more on the products that is there in the cloud rather than in the cloud services as such. So if you ask me, AWS, Microsoft Azure, GCP, those are the most premium clouds which majority of our customers prefer, and we also recommend them to the customers. But then is that totally safe, or what are the problems that it brings with? So in an industry, when any company comes to us, we tell them that, okay, if you are essential that you need to scale, then use cloud. If don't, then no need for a cloud. You can even host anything in a server, like in an on-premise server, if it is totally based on your LAN network. If it is if it is an application which requires only your employees to access. But then now what has happened is everybody has a device. Now, when it comes to the device, it could be any device. I remember when we were approached by a logistics company, they came to us and said, can you help us or can you help our employees track the package and also make a route, that is a minimum route that we can, or the employee has to go to drop this particular package in the address. So it is more like a the information that has to come. Now there will be a lot of routes that comes, like he has to deliver a package at a certain place X, and then there will be 5 or 6 packages which he has to. So it's more of a traveling salesman problem. That's what we call it in the operational arena. So a traveling salesman problem is where he has 5 packets and he needs to optimize that. How do I travel so that I have to travel minimum in order to deliver this 5 packets? Now this with the help of, I mean, currently, if you ask me, it's pretty easy when it comes with, when we are using the logic of like the Uber. If you are going from place A to place B, the Uber takes you through the shortest route possible. Again, they are collaborating with Google Maps because they have the data available. And if there is a traffic in place, then they kind of reroute it, right? So if you ask me, this has been empowered or enabled with the help of cloud computing, right? And yeah, then yeah, sorry about that. Yeah, when we are looking at cloud as a service, or as I said earlier, we are also looking at cloud as a business innovation tool. Now, what does business innovation means? Basically, when it is more to do with the process, or when it is more to do with a technology. So
PPT is
many,
not visible, sir.
sorry. Oh, sorry. My bad.
PPT, sir.
Okay. My bad. Sorry. Are you able to see now?
Yes, sir.
Okay. So when it comes to cloud computing, or when it comes to business innovation, so now most of the business innovation or the definition of the business itself is changing. Now earlier we were discussing. Now there were banks. Now when people does not visit bank, one of my friend who is actually a bank manager, who is in a probation officer, what he said is, there are banks which are running on the revenue that is generated by ATMs nearby. So that is the scenario which they evolved to. Then they started cross-selling insurance. And at a later stage, when UPIs came along, when there was Paytm, which was acting as a branch or acting as a bank without a single branch, it's all over the internet. And then at a later stage, when blockchain came into picture. So we are talking about different technologies which doesn't require a physical space. There are no longer brick and mortar shops that is required to run a business. Even every YouTube video that you see now is kind of telling you, okay, you can start a business even without having a place. If there's a virtual space that is required, all that is required is a cloud space. If you ask me, what is a virtual space? It's a website, and then based on their website, where is it hosted? It is hosted somewhere in a cloud, and this particular cloud is telling, irrespective of how much traffic it gets, you can scale up. So it's basically exploring your hope into the cloud, into a space, into selling it, and it is even made it really accessible for anybody. Okay, and now what are the advantages by which we can get it? Now, if you ask me, earlier when we had to set up a cloud, we were just given, okay, now I'm sure all of you would have heard about infrastructure as a service, platform as a service, software as a service. Now we are also hearing BaaS as well. Okay, now real-time monitoring is a advantage which we have. Like there are different tools by which we will get to know what is the advantage that, or what is the traffic that is happening in the cloud. Do I need to scale it down, scale it up? And this most benefit comes in terms of the amount of money that you need to spend based on the traffic. So if there is a high traffic, you need to scale up, you are able to spend only that much. And if it is the time of say like your quarterly results, the example I was giving, or it's the time of the black sale for a e-commerce site, so you need to make sure that irrespective of the number of hits, be it even 1 million, so the site shouldn't crash, because that is the lifeline, the bread and butter. And this 12 hours during which the Black Friday sale happens, the site has to be up and running. So what is required is real-time data. And again, let me give you another example of real-time data. I'm sure all of you would have used this Instamart or Zepto. So if you try buying vegetables, let me give you the example of vegetables, because I myself have had this experience several times. When you order in the system, there is always, like, if you want to say one, for example, 1 kilogram of tomato and 1 kilogram of potato, and you keep the order. By the time you place the order, that is when the real magic happens, because the instance when your front end or your mobile application is seeing that 1 kilogram of tomato and 1 kilogram of potato is there. When you place an order, and when this place order button is clicked, the API behind goes and gets the actual units or number of units in the warehouse. Then if they don't have this 1 kilogram of tomato and 1 kilogram of potato, which was shown to you in the front end, then they will not be able to cater to it. Then it is an unhappy customer. It is a lost business. All right. So that is where we are talking about latency. And if the instance which is there in the mobile, that's the data instance which is there in your mobile, is really giving you real-time data. Because earlier we used to talk about real-time data, near real-time data. All this is very essential, especially where the example which I told you about the tomato and the potato. So imagine if people, or I myself, who was earlier purchasing the vegetables from the shop, after two such experience where I ordered for 1 kilogram, but the system logic reduced it to half a kilogram based on what is available in the inventory and based on how they can cater to maximum number of users. That is a business logic which was written. I started not placing orders, but instead I directly went back to my older vegetable shops. So now you understand how a business will be impacted if we are not giving them proper scalability or real-time data availability. All right. Now, similar is the example with supply chain, where we can have a robust and agile information pass through. And I remember where this particular Amazon. Now everybody is in Amazon. So now Amazon returns because this Sunday I placed an order for a small item. But because I was not able to find that item and my son was pestering me, I thought, okay, I will buy it because it was costing only 120 rupees. And this Amazon Prime has kind of made me really lazy that irrespective of whatever price it is, they don't charge for any courier. So I'm happy. Even if it is costing me some money, I've become so lazy that I will go and order for it. But what happened is, after 20 minutes of placing the order, my son really found out that it's an item which is available in my home, and he found it out. Then I went and after 30 minutes, when I came back home, he said this is available. So I went and canceled that order. Now, what I'm seeing is the information which I am available, or which is available to me, states that by the time, that is the duration, by in between the duration of this 1 hour, the particular application or the particular thing has been packaged and it has been sent to a common warehouse. And this is happening in between Pune and my location here in Kerala. Now from the Pune, it has started, it has went to the Pune Amazon warehouse. And by the time I clicked, then that information which came on the next day states that my package received in Bangalore. Now, this shouldn't even move from Pune to Bangalore because I cancelled it before. But the information did not reach the logistics people on time, or it was already parceled for a flight journey from Pune to Bangalore. So my parcel, irrespective of me cancelling it, has made a journey from Pune to Bangalore. And then after 24 hours again, I'm seeing that it has moved back from Bangalore to Pune. So there has been a logistical travel which was totally unnecessary, and it could have been prevented if the system was much more robust in nature. All right. So we would think that it is really trivial. However, I'm talking about a 100 rupee thing making a business flight, and that 100 rupee thing would have been less than 100 grams. But for logistics companies, saving such things really matter. We are talking about Apple companies saving in logistics by cutting down on its charger. Okay. Now coming to the final, that's a low latency edge. Now we are looking at the the latency. So we were discussing about the data transmission delays. So if the data is transmitted on a faster real-time basis, then there is a lot of information exchange that can happen. Now imagine in a particular shop floor, or in a particular, I'm sure in all service systems you will be, or imagine you are giving a vehicle for your servicing. And in every servicing center, mostly you will see, there will be a television which says this particular vehicle is in progress. So that visual radiator is there, and this visual radiator is connected with a device which is currently with the technician. Now this technician will be connecting this device to your vehicle. Now gone are the days where they go and repair. It's all assembly now, and even if it's in repair, they will not repair the sensor, but instead they will just replace it. So every workshop has now become an assembling unit, because it's not worth repairing it, but it is assembling is what is actual process that is happening. So they will just make the change, and you will be able to see that in the visual radiator if you are in that place, or you will be able to see it in your mobile phone, or you will be able to get it in your website, or you will be able to get it in your SMS, right? So that is the level of industrial explosion, or that has really happened. Now, before I proceed, any questions so far? Or am I audible?
Yes, sir.
Yes, sir,
Yes,
you're
sir.
audible.
Okay. Okay, fine. So I believe there are no questions. I will proceed to the next slides. Now, coming to the business benefits across different sector, most of this have been covered through my story, where the cost efficiency, we are talking about the capital expenditure and operational expenditure. Now, what a capital expenditure is basically, if in a company like TCS, we are purchasing laptops, then that is a capital expenditure, because we are investing in a laptop which has to be used for the organization. And if in a petroleum company they are investing in a machinery which is used for refinement, then it is a capital expenditure. Now coming to the operational expenditure, it is mostly salary. Now when you speak about the cloud computing unlocking the business benefit, then the cost efficiency is of primal importance, because we are looking at the reduction in capital expenditure. You don't have to buy money in servers, but instead you can purchase, or you can lease, or you can just give money to AWS, and then you can get your cloud instances, and they will make sure that your business runs promptly. And if your business is having a downtime, then you need to pay only as much as necessary. Yeah, as you see, it is pay as you go operational expenses. So reduction in operational expense, and shifting from capital expenditure to operational expenditure. Shifting as in from the on-premise server which was there in your computer. I'm sure all your computer labs, if you go, there will be something like a rack server where you will see a glass, or sometimes it might be an air-conditioned room. So the air conditioning expense is there. So the rack server expense is there. This lab assistant has to be there. I think lab assistants will be more of an operational expense. But then the all the hardware infrastructure which has been purchased in terms of the capital expenditure is now moved to or migrated as operational expenditure. So there has been a change in expenditure nature. But then, and also operational expenditure is very less than the capital expenditure. Now coming to the global agility, we can reach out to servers in the globe anywhere. Whenever I get a call from any of this people, like mostly from the banking area, they will tell, sir, why don't you invest in stocks from Google and Tesla? I said, come on, yeah, I am in India. How can I do that? They will tell me, you can do anything, sir. Sitting here in India, you can invest in that. I said, no, it is a very share market thing. They said, no, you install this application, you will be able to reach out, and you will be able to within seconds. So we are talking about a fraction of a seconds, where even if the value of that share increases by cents, or if the value of that options increases by cents, we have to place the order. So now we are talking about global agility, which is making the world seem like a very small place. And coming to the advanced security. Now, security is basically, if you ask me, it's a double-edged sword. We look at security from different standards. Extremely sorry, it's actually SOC standards, and then HIPAA, as well as the global data protection rights. Now, coming to security, there are different countries which has different set of security. Now, in Europe and all, GDPR, or the global data protection, is considered very high, wherein any personally identified information, the PII, or any data which can indirectly lead to you, that is your phone number, your PAN number, something of that can also be, you can't allow it to be directly dealt with. Okay, so what the cloud is currently doing, they will tell, okay, we will store only the hash value of it, which means nothing but it's a secured hash algorithm. Most probably they will be using a SHA-256 or something, and then they will store it in a very secured fashion, is what they say. Okay, and now which will kind of prevent your SQL injection or data leakage in the cloud, which is much more secure, is what it is claimed to be. However, when we go more for an AI, also the same thing is coming as a contradictory thing. How secure is my data? Now coming to the workforce transformation, we said earlier the businesses is transforming from different. Now banks are becoming insurance selling places, or any potential application is becoming a bank. Even the WhatsApp, which I used to chat only, is now allowing me to send money. So I don't need to bank. I can send money in the night or in the morning, irrespective of the time. Okay, so business is transforming. So similarly, the workforce also has to transform. Now I am able to sit at my home and discuss with a customer in a different location. I am here to sit and I am able to talk to you who are from different parts of India, all with the help of the cloud. And also during the time of COVID, especially when there was this education through that's online, that's a screen-based learning, then it was more of a cloud people who really benefited, because they were selling products which could be hosted, and then you just need a cloud instance. So it's more of a subscription basis. That is, the channel alone was we used to call it the channelization. Like if earlier you need to buy a product, then when it comes to channel, you just need to subscribe, just like a Netflix basis. Fine. Now coming to the road ahead, what are the emerging trends? We are looking at serverless computing in the future, wherein the infrastructure. Now coming to cloud itself, I'm sure you would have heard about technologies like Docker and Kubernetes and all, where we, instead of having a in a cloud or in a VPN or in a VPN tunnel. So VPN is nothing but it's a virtual private network, wherein using VPN, we go to a virtual space, and inside that virtual space, which is created by my customer or by anybody else, I will be going and sitting and working there. And an entire Windows machine would be churned up over there along with a set of applications that I need. If it's a bank, then I can just have every bank connected to my server, and inside that particular server, I'll be running my Finacle application, which will be making my application secure from the external environment. Now, all this can be done with the help of a cloud. Okay. Now, coming to the emerging trends, we are looking at more such virtual instances where we don't need a server in place, but we'll be able to make sure that the end data is correctly transferred to the place where it is required. Now, coming to the 5G integration, we are looking at Starlink. I'm sure all of you have heard about Starlink, where our own favorite Elon Musk is using his satellite to give us internet. And gone are the days where we used to wait for movies to be downloaded through torrents in hours. We can now get it anywhere. Now we are speaking about the ultra low latency. Okay, now I mean we live in an era of hyper and ultra hyper personalization, ultra low latency. All right. And then coming to the AI adaptive service. Now, if you ask me who benefited the most out of AI, I would say it is mostly the cloud people, because they were able to integrate AI into the particular application and they were able to sell an instance. Now, what you are basically getting is a AI instance in which you need to pay for the tokens. And this particular tokenization, obviously for the large language models, there is token cost involved. However, the cloud was able to sell that as a service, and we really do not know what is being given by the LLM is really in or out. So the benefit is mostly to the cloud. All right. And then coming to the quantum computing, I'm sure all of you would have heard about bits and bytes. Currently in the computer world, we work with ones and zeros. But in terms of quantum computing, we work with something called as the qubits. And speaking a bit more about qubits, has a value in which it is not just 1 or 0, but it can assume any value in between this. And it is totally to explain. I believe there is a concept called the Schrodinger cat, in which the Schrodinger says, where you never know whether the cat is alive inside or cat is dead, but it can be in any stage between this, right? So that is the level of computation through the help of a that's the quantum computing basics, or the qubits as we call it. All right. And now why is it important is, once this quantum computing is in place, it is said that we can make the calculations really fast. Now, why is it this calculation fast is kind of scary is because I gave you the example of SHA, SHA-256. Now, SHA-256 is successful because we are telling there is 256 characters, which is kind of like if your name is XYZ, you pass it through SHA-256, you will get a certain set of value, which cannot be you put any other character, it will change XYZ1, then it will not be the older one, but instead it is a different hash value altogether. But what we are telling is, if with the help of quantum computer, you will be able to do trial and error, and then you will be able to convert back your hashing into the real value, and you will be able to see what is the actual value. So we are basically telling that with the help of quantum computing, we will be able to decrypt anything and everything in the world. And this was a primary reason why blockchain did not become successful, where we said quantum computing will literally tamper blockchain, because the distributed ledger technology in which it worked, the secured hash algorithm in which it worked, will be totally going for a toss in the quantum computing world. But now we do not know. If you ask me, technologies like blockchain, technologies like AI and all, the world itself is not ready for it, is what I believe in, because we live in an era where trust cannot be exponentiated. And in a technology like blockchain, where the trust is in the system, we still need a bank for us to send money from A to B, and we still need a help desk where we should call. Else, trust in the system is totally a scam. At least that's what I believe. Okay, now coming to the critical challenge. Any questions ahead? Sorry, any questions so far? Okay, I still believe I have 30 minutes. Sorry, 45 minutes more. Any questions so far? Am I audible?
Yes, sir.
Okay, fine. So I believe no questions. Now coming to the critical challenges, the data privacy and sovereignty. Now, especially in the era of AI, where this large language models is trained with the data sets which is spanning in the terms of 10 to the power 28, 10 to the power 30. We were talking about GPT 3.5, GPT 4, which had this set of data sets, and now we are talking about synthetic data, which itself is being created by AI. Now, imagine whatever data we give to the cloud, we never know whether this particular data is used as a tool to train or not. Because imagine when my photograph is being taken and uploaded into the LLM, and it generates a picture which does not seem like me. It has been trained with a lot of data. However, tomorrow we never know whether my data is being used for some malpractice. So similarly, data privacy is always a very big challenge when it comes to cloud, because we never know where is it hosted or where is it used for, or are they really using it for some other purpose? Because if something is given free to you, then you are the product. At least that's what we need to learn from the social media era. Because if you are in, if Instagram is free, your Facebook is free, and any other social media which is given to you free, then your usage, your analytics, your data is being used back as a tool to sell things across to you. That's the data which we have to make sure that is that we are dealing, or that we are putting into cloud is secure or not. I'm sure you heard about the cyber attack that happened in Tata Motors. So there we had lost dollars in billions, because the plant was not able to produce cars for 30 to 40 days. Now imagine the loss that is there, and imagine the reputation loss. So stock market share prices plummeted. So there is a risk in which if a particular system is not secure, be it any company, the data. So then again, coming to the security threats. So yeah, cyber attacks. We were just talking about cyber attacks, and so all this vulnerability is there. And let me give you this example. If you go to the nearest ATM, you will never find the latest operating system of Windows in the machine. The business expectation or the functionality of the ATM is to give you money. That's the level 1 expectation, because level 2 or level 3 is the user experience. So if you ask me, do you really need the latest cloud or the latest latency when it comes to money? I would say no, because people are ready to wait for a couple of seconds in terms of security. So real latency or latency in case of banking needn't be the first priority. But if it is a gaming arena where you are doing gaming, or if it is in the share market, the latency should be really, really low. And so that is where we said, based on industry to industry, the cloud demand or the cloud this thing changes. Now coming to hybrid environment management, we are seeing on-premise and cloud resources based on risk of the people. Like I was telling, for banks itself, there will be a master data, there will be a master copy, and this master copy will be updated only on a daily basis, because we can't afford to have a dynamic data change everywhere. But instead, the bank will have a copy and the ATM will have a copy. And once you take the money, this particular data will be passed on to the bank and their balance will be overridden. Okay, and then that message is what comes to you, right? But then the master data copy, which is there in the bank, has to be overridden at the end of the day. So this is a particular hybrid environment where there is a on-premise as well as a cloud, or this acts as a backup feature. What happens if the entire cloud data is deleted? You have a backup, right? So that backup is really, really essential. Okay. Now, yeah, this was something which we discussed earlier. Now, every transformation project, every project which is calling itself digital transformation, cloud computing remains the backbone, and digital industrial revolution and operational excellence. So till 2030, this will be there, and this is going to, or I mean, in fact, it is already there, and we have a lot of transformation projects which is in place. Now, any questions so far? Because from here, I think we'll be moving on to a bit on edge computing and how is it beneficial to business and things like that. Any queries?
Yes, sir. You just mentioned about blockchain,
Yes.
some
Correct.
words, but is it really blockchain is in cloud environment, or it's undermined a separate link altogether?
Okay, let me give you this. If you ask me, blockchain is a collection of a lot of things. One is it has a secure hash algorithm, right? And then it has
Yes.
something. Okay, then it has a distributed ledger technology where everybody has a copy. Okay, now even my potential laptop can be a potential source for the blockchain. Now, if I have 10 or 20 computers, and my computer is also being a potential source. Now, I'm sure if you have used torrent earlier days, you want to download a movie, and 5 or 10 people who are already connected to the internet has a movie. So you're downloading it in bits and pieces from all of this who has that same torrent, what do you call, tenant installed. All right. So now when it comes to blockchain,
Yes, sir. My
yes.
question is it running on clouds?
No, it is running on different servers, which where your potential laptop is also a server, sir. So the concept of entire cloud cannot be put into a blockchain. But in if you are asking me whether there is a server somewhere, then there is a server somewhere. But it is not just a collection of server alone, because computation is also happening at your system. Did I make myself clear, or did I confuse you more?
No, confused. I'm clear. Okay, thank you.
No worries, sir. Thank you. So coming to the evolution part of computing or the cloud computing as well, we initially had this, if you ask me, operating system. Now there was primarily Linux and primarily Unix, and where we used to interact with the help of shell scripts. Now the difference between a script and a programming language is a script is something where you directly interact with the kernels, And inside this kernels, you are giving instructions to this particular kernels in which you ask them to process a certain set of this thing. Now, this was the first server. If you ask me, this operating system was the initial or the first level of server that we had. Then we had the client server in terms of the communication, because we had a client in our machine, and then we have a server in place. Now, the operations can happen in the server after my client gives an instruction, because in this place, in this Unix, it was more like I am directly giving the instruction to my kernel, and that is processing. Now, this client server came. Then comes the cloud part to it, right? And then finally comes the edge computing. Now, edge computing is one level above the computing, because we are looking at the final places where this data is getting calculated to do the computational service. Now, there are drawbacks to it as well as there are advantages to it. Now, imagine, how do I put it? Okay, I'll give you this example of a pacemaker. Now, I remember when we were working for a life science customer, the life science customer came to us with a demand that if a person who is having a wearable, that is, you know what is a wearable, right? It is like a digital watch. Nowadays, everybody has it. Now, this particular wearable is connected to your mobile phone, okay? And this particular wearable can be connected to your pacemaker. Now, based on your pacemaker's battery, it can be shown in your this thing. That is your watch. And what they wanted is basically, or what they already had is, because a company like TCS does not have the license to produce medical device. We call it so-called medical device. But then based on this pacemaker or the heartbeat, if the particular heartbeat is going down below, then this particular device that you have in hand will take a decision that there is a potential cardiac arrest, and this will intimate an SOS message to whomever your relative is, or if it is a alarm that you have to sound, then it will sound an alarm. So that was one utility which they said can be provided to people. But then this requires something which is like a where my device or particular my end user device had to take a decision. And it is not sorry. Okay. Yeah. Okay, madam. I think I'll please be on mute. Now coming to the edge intelligence. This particular edge intelligence has to be in place because it can't initially go to sorry, I was also muted in the process. Now, because this edge devices also will have a set of logic which needs to be processed. But it is always better that such edge devices is required. But then it cannot be applied everywhere, because we are talking about a wearable device in hand, or we are talking about a car which can send an SOS message if it is airbag is automatically thing, or we are talking about an ADAS system, an advanced driving automation system, wherein it sees a particular danger and it stops on its own. And now we are also talking about vehicles that comes with ADAS level 2 or level 3 feature, where I don't know whether it's going to be driving on its own. Now, this particular set of devices will not communicate back to the server, but instead it will directly take decision on its own. So that is something which we call. Now we have the cloud, we have the edge nodes, and finally the edge devices which it interacts with. Right? Now this is what is basically edge computing. Now, is edge computing good? Yes, because it provides a lot of things. It will, it can be put into, as we said earlier, what is called as a hyper personalization. It can give you instructions like, okay, if you're a person who is not drinking water, it can give you instructions based on your skin, this thing that is tone, whether you will be, you need to drink more water or not based on your skin moisture. It will be able to do that. So that is all intelligence being pushed to the end. And then there are areas wherein the particular cameras, if it detects a particular motion, only then it will come into picture. Only then it will start calibrating, and then it can even count. Okay, this is one person going, and then how much is the count? So all that edge devices will be there. Now coming to benefits. Now, why do we need edge computing? Because we are looking at a lot of data, and even analysis of this data is getting in teraflops. If you ask me, you see the picture, right? So gigabytes of data is now in terabytes of data, and terabytes of data has to be crunched or sent to the server, which will again make the system really slow. I mean, slow as in the latency. When I'm saying slow, it's only a couple of seconds that I'm talking about. But we are living in an era where my daughter will get impatient if he or she is not able to get the entire thing downloaded. I'm sure all of you or all of people in our age, we don't mind even if the internet or the streaming gets stuck for 1 or 2 seconds. But just observe the new generation. They are really unhappy when the particular video is stuck for a couple of seconds. They are really unhappy. And I am thinking that even my 100 Mbps at my home, even if when it is stuck, then I mean, how would they have survived during my school days where I did not even know what internet was? So we are talking about the next generation of edge computing, wherein the intelligence is at the edge, and we are not talking about sending the data back to the cloud. And this is good. However, there is a flip side to it. We will discuss that. Now, advantages: it will reduce the latency, it will run the edge applications with much more robustness, because the application doesn't have any connectivity to the server or to the cloud by which it is required to work. And then there is no problem of denial of service, distributed denial of service, all that security checks and all this particular application need not face. And emerging technologies such as autonomous vehicle, Internet of Things, robotics, drones and all, very real application, because I'm learning more about this application of drones during the war that has happened recently, or the conflicts, because we are talking about drones, and they are even being used as a weapon in area. So a lot of research is happening, and the edge computing services, only if the drone sees it's a potential target, it needs to go and attack. So a perfect use case for edge computing, but on a negative sense. Now, negative and positive again is relative. Okay, then coming to migrating to edge computing, we can can there be centralized management possible? We can even manage some of it or part of it as we need. Then interoperability of equipment, yes, it is also possible. Then coming to APIs or extendability, it is flexible. Now, we were discussing earlier about the headless application. I think I spoke to you about headless application, because earlier we had something called as a monolithic application. From the monolithic application, we went to headless because technology agnostic is something which we wanted to have in place. And then also we have support updates. Right. Then coming to the problems with edge computing. Bad configuration is a really poor thing. Then hacking vectors, or the areas by which the hacking can happen. That is, you just need to hack that particular end device. If your this thing is tampered with, or if your vehicle ADAS system is tampered with, then you can easily land up in crash. However, it is not necessary that the company that gives you ADAS will check, but then any tampering with this logic will defer you from insurance. So there is problems of such nature that occurs, and then individual licensing cost will increase.
Thank you.
If you, I think somebody will have to.
नाही मी लेक्चर मध्ये वगैरे होती
आणि
आणि मग
ma'am.
त्याच्यानंतर मी
Yeah, sorry, I was also saying, but then imagine where we said from the advantages of computing, we moved from the capital expenditure of on-premise cost to a operational cost where licenses did not have to be purchased. But now we are looking at a personalization where licenses will have to be purchased. But then this is more of a cycle which is in a kind of sine wave, where in one trend it will be in place, but then at a future trend when we go for personalization, then it will be in this thing. But after some time there will be some other problem solved, and thus it will go in a cyclic fashion. Right. Any questions so far? I think no, I still have time. Okay. So right. So coming to artificial intelligence, there is a lot of potential for cloud in artificial intelligence, because what we are basically getting is a dependency on usage of this particular application. We are using LLM, which has been hosted in a cloud. So there is a lot of traffic that is happening in the cloud, which is kind of beneficial to the cloud, because what they want is scalability. If everybody is getting prompt service, then scalability is happening and you are dependent on it. And then the tokenization will also happen. So even if you give cloud charges for free, you can charge it back as a token cost, and both are happy. That is, the service is getting robustly available to the end user, and the cloud services are also happy. It's a win-win situation. Now coming to event-driven architectures, that is only if it is on a need basis. That is on the prompt event, if it is triggered, then only it needs to be in place. And so that is a very big technological advancement. If you ask me, it's a transformational process. Now coming to next generation user interface, it's not just Internet of Things or it's just the sensors, but you can integrate it with literally any potential light changing or any smallest. I was talking to you earlier about the heartbeat. So think about it, any life or any change in technologies, like how do I put it? Okay, now imagine, let me put it into scale. When Palestine was when there was an attack, we were talking about like 4,000 shells being dropped in a fashion, and out of which there was this anti-resistance system which kind of stopped 90% of it. So think about the efficiency or the effectiveness. Anything that was moving was being shot down at the air itself. So we are talking about event-driven systems, not architectures, but event-driven systems. Now, IoT systems, we discussed next generation user interface. That was what where we came to this point. Now, again, it is drastic change that is happening in what cloud is enabling us. Now, coming to quantum computing, we are still taking baby steps, but Google has declared that it has achieved quantum supremacy, which means it is able to stabilize and at least make some calculation with the help of quantum computing. Now, I really do not know how the speed of that will be measured, but let's wait and watch. Then coming to real-time situational awareness, okay, now coming to IT companies, if you ask me, IT companies like TCS, where there is less of research, more of operation, we tend to study about all this. We tend to study about the progress which is being made by these companies. And many a times there are technologies that come in, but it goes as a hype. Now we were talking about blockchain earlier. I remember in 2017 when we were going to customers, everybody wanted to join the bandwagon, but then they were not able to get into it because they did not trust the open system. But then when IBM had their own blockchain system called Hyperledger, which could be used, then everybody wanted to do it. But the entire hilarious thing to be noticed is that once you have a control over a system, then it is no longer a decentralized distributed system. So a decentralization is lost when you give the control to it. So it is mostly to be noted that similar is the scenario with the AI. Now we don't know the potential of it. It has a lot of use cases. Does business trust it? We do not know. There is a lot of hype around it. There is a lot of chips being made by NVIDIA, which is being purchased. There is a lot of companies which are interconnected and they are giving service. But however, has results being drastically transformative or disruptive? I believe this terminology was there in the book. I'm sure if you get a chance, there is this book called Innovator's Dilemma. Please do read through it, wherein you will read about something called as a disruptive. Now, internet was a disruptive technology, but then all these technologies should be tried and tested. So similar is the case with AI. Now, have we tried and tested it? No. Is there a lot of hype around it? Yes. Are we sure it will work? No. So whatever example I gave you earlier, if I have to put something in the ATM near me, I don't need the latest operating system. I just need the ATM to spit out cash when somebody in need comes to it. So similar is the case with AI. I don't need to give it any gibberish, but I want to give it answers. However, the beauty of AI is we are very longer looking at AI. I believe it is after agentic AI, we are looking at AI trainings AI. So that will also happen in 2 years' time. But then it is again something for the system or the countries. Only if there is adaptation of technology will it really catch up. Okay. So I think yeah, with that some gardener's insights. Nothing more from my perspective. I believe I had only prepared for this. Coming to IT vendors. IT vendors like I was telling about TCS and other IT vendors, where there is a change in business model, we also have to adapt. We have to learn what is happening. And then the evolving nature of cloud computing, I mean, lot of predictions, lot of hype cycles, lot of quadrants. Then there is vendor faces the use of a new business model emerging. So, I mean, whenever there is a change in business model, we also have to make sure that whatever we do is of value adding to the business, else we will go obsolete. Right. So I think with that, I come to the end of session. It's only 7:10. So I am open to any questions. I see total of 77 people. I'm glad, because when I started, it was only around 30s, but now 77 people have joined. Really happy to see a huge crowd. Anything that you wish to ask or discuss, sirs and ma'ams? Am I still audible?
Yes, sir, you're audible.
Okay. So any feedbacks are also welcome. If you have some examples, anything that you want to share, feel free. And just to understand, this is a 7-day program, is it?
6 days.
Sir,
6
it's a
days.
6-day program, sir.
Okay. Okay, Ramani ma'am. I see. I think the next session is yours, right?
Yes, it's okay, sir. It was so nice to. I was listening to you.
Okay.
I'm sorry. I do not know how I'll go about the next session. Sir, so what do you know? What is your say for the researchers?
Yeah, from a research perspective, if you ask me, they mostly are looking at how can cloud integrate AI systems into it. That is first thing. Okay. And secondly, they are looking at how can we do quantum computing integration, because currently we are looking at only quantum supremacy declared by just one company. Now we just can't rely on, or we just can't be waiting. From the researcher's perspective, you will find very less in terms of cloud in the area of research. And yeah, but then again, it has really helped research in terms of there is tools like EBSCO. There is other research repositories which is now available in cloud, and a lot of papers, whatever has been written, the white papers, the thesis, the hypothesis, everything is there available in cloud. And whatever you need to search, because earlier if a researcher had to go through a 100-page paper and then only derive what is required, currently whatever is relevant is totally available for them. And clubbing the particular cloud capability with the large language model learning capability, you are now able to search with the contextual keywords, and this particular contextual keywords will give the researcher whatever is relevant. So from a researcher perspective, he needs to spend less time. That is in terms of industries, I was telling how innovation has been expedited. Similarly, research time can be reduced. because this will give them the right set of insights. Ramani ma'am.
Okay, sir.
Right.
Thank you. Yes.
Thank you so much.
Sir,
Anybody?
I express my
Yes.
my understanding. Then you will
Yes.
tell me whether it's a right or no.
Sure, sir.
See,
Sure.
when you use a client server concept,
Correct.
right? Server is a
Right.
central point for processing. Client is
Absolutely.
accessing.
Client is accessing.
Either
Yes.
applications are taking data from the server. It's the client side. That's the user side, right?
Correct. Correct. Correct.
But here, the question is here we are referring edge computing, edge nodes, edge applications. All are
applications.
from the client side.
All are from the client side. Yes.
Yes, that means client server, you are replacing the cloud processing point and the client side, which is referring to the edge. Am
Absolutely.
I right?
The processing happens at the edge itself, sir. The processing happens at the edge or the edge node.
Okay, sir.
It doesn't
Thank
have
you.
to. It doesn't have to go to the server to communicate, because we are looking at so fast systems that by the time you go to the server and then come back, the accident would have already happened. The ADAS would have already crashed.
No,
Thanks for the
sir.
question.
Cloud service also it's a part of a source, maybe source from the some supplier or service provider.
Correct. But then we don't go to the
physically there is a computer system.
yes,
Though
yes,
you are
physically there
using
is a,
cloud.
yes, sir.
Okay.
You're right. In terms of the server, where there is a physically there is a computer system, but where I'm talking about the edge computer, we are or the decision is being taken by the edge edge system or the edge node. So it will not go beyond that.
Okay, sir. Thank you.
Okay, thank you so much. So any more questions, discussions? I'll be more than happy.
Dear participants, if you have any more queries, you can post it in the chat box.
Right. So if there are no more questions, I think I'll hand over to Parvati for bidding me farewell.
Thank you, sir, for the valuable and informative session. It was indeed an honor to have you with us, sir. Thank you so much.
Thank you so much, Shani madam. Thank you.
Yeah.
Thank
We'll
you,
be
Jacob,
starting our
sir.
next
Thank you.
session. We'll be starting our next session at 7:30 p.m. We'll take a short break till then. Good evening. Welcome back, everyone. We now move on to the second technical session of day 3 of the 6-day ATAL-sponsored online faculty development program on advancements in cloud and edge computing, research and industry perspectives. The second session focuses on highly relevant topic, cloud in education, which explores how cloud technologies are transforming teaching learning processes, academic administration, and digital education ecosystems. It gives me great pleasure to introduce our second resource person for the day, Dr. Ramani Baivi, Professor and Head, Department of Computer Science and Engineering at Adi Shankara Institute of Engineering and Technology, Kerala. Ma'am brings with her rich academic experience, strong leadership, and deep insight into integrating cloud technologies in higher education. Her session will provide valuable perspectives on leveraging cloud platforms for effective teaching, learning, and institutional growth. Ma'am, we are truly honored to have you with us. I kindly invite you to take over the session and share your expertise on cloud in education. Thank you, and over to you, ma'am.
Thank you, Shani. First, let me apologize for my sore throat. It got infected yesterday evening, unfortunately. But no, I tend to crack my throat further to make this session effective and useful for all the participants here. I need your wholehearted support and cooperation in participating in this session. And whenever there is a discussion, I want all of your involvement because as Shani said, this is a high relevant topic for all of us, including us. The during the inauguration, I told we had a purpose for proposing this FDP as we want to learn, then adapt ourselves into the cloud technology for the sustainable growth for the faculty members, students, and the education sector as whole. Let me share my screen. Whenever, whatever I speak, if that is not clear to you, or if my voice is so feeble, you are unable to hear, please let me know. I shall take care of it. Screen visible to everyone? Hello?
Yes, ma'am, it's visible. Yes, ma'am.
Okay. Okay. Cloud in education. Again, for now, for the first few minutes, again, we'll be talking about cloud. Then slowly we'll get into the agenda of this session. Let us understand what is cloud. Cloud, we all know well that it is an infrastructure. For example, when we take, if I want to light my room or house, I need to only, just, uh, switch on, just press on the switch. So if I just make it on, then I'll get the service will be provided to me. I need not to go and generate electricity or build the power plant for getting the current or the electricity. So that is one utility. Or you can participate in generating the electricity, or you can participate in the maintenance and distribution of the electricity to the various nodes or the client points. The cloud is also like that. You can use it, and the same electricity I can, once I'll get the electricity, I'll use that electricity for some other purpose, or I'll make it use for generating something else. I use it for my microwave for cooking. I use it for ironing my clothes. I use it for refrigeration. I use it for pumping water from well to irrigate my field. So various things I can use use the forms of the electricity can be converted. I can use that. So likewise, you can either use the infrastructure, or you can create the infrastructure, or you can maintain it. So it is a choice. again, it is a choice of having it or not. And if I am, no, it's my personal choice whether I can live with the electricity, or I can live without electricity. It is again a personal choice. I can live without electricity as well, but I have to be ready for that kind of life. This is so thing with the cloud as well. So cloud is an inevitable infrastructure, especially in the computing world. Either we have to embrace it or not. It's our choice. Again, taking the security aspect of it. When we keep our valuables, on an earlier age, we used to keep our valuables and gold and other things in at home. We'll keep an almirah, lock it multiple times. Then we'll keep a separate room for it, and somebody will be safeguarding it. We'll keep some dogs, other things. How much more valuable that we store at home, that much care that we have to give it for safeguarding it. And we'll see that even if you go out, it will take care of its safety, so it will add certain pressure to us. And slowly, the public locker systems being offered. So we used to keep our the valuables in the public locker, that is in banks. So we can go and hire a space. Either you can go for a small locker, bigger one, and with some other attached access as well. For example, if you give some chemicals, you need to have some climate or AC attached to it. You can pay and do that. And it's the same thing. I know you can keep your valuables in the locker, and your private key is being given to you. And what you keep, what you use in that space, it is up to you, and nobody will take care of it. And whether you keep it safe or lose it, it's up to you. But there is a public security system. They will keep security of the entire thing, all the lockers. But what is inside my space, the locker, that is my responsibility. So with cloud as well. Say whether I'll go for a very safe, public security, or I'll take care of my infrastructure to safeguard things on my own. So with this understanding, we shall move on to cloud in education. Okay, so I have designed this session with uh, 6 subsections. The first one is the technical convergence. So please pardon me. So here also will be understanding cloud in the previous sessions, like this here also, but in the academic perspective. Then industry roles. There are now in education, there are let us understand the stakeholders in the education. Obviously, the curriculum, that board of studies, it will be offered by university. Either it can be deemed to be university or central university, or no, your autonomous body. Then you have the infrastructure to deploy the curriculum. That is an institution, classrooms, labs, and other things. Then you have a people to deploy the courses, faculty members and the staff members in the lab, and other supportive staff to run the institution. Then the main stakeholder is the student. And the here, how do we embrace cloud in the perspective of students? In the second section, we are going to deal with that industry rules and the real world stack on cloud. Then coming to the campus, cloud architecture in the campus, how we can automate things, in the campus activities and data, that we are going to discuss in the section 3. Then section 4 is a continuation of that. So what are the tools and ecosystem for the faculty members and students, for us to embrace the different technologies over the infrastructure on cloud. Then we have the curriculum design. So here again, we focus on indigenous, national-wide institutions, how the premier institutions in our nation, adapting, changing themselves in the growth graph along with the cloud. So we'll take certain examples and we'll move on with that. We'll learn that. Then we'll discuss on the challenges, and we'll have the summary of this session. Then we'll have an open discussion on this. So before continuing with that, let me ask. I just ask if you have yes as if the S is your answer, please type it in the chat window. Are you from deemed to be university? Any faculty member or student from working in or studying in deemed to be university, private universities? Yes or no? So do we have any faculty members or students studying or working in MHRD institution? Yes, Dr. Manak. So that is NIT, IIT, Triple IT, Kottayam, like institutions. Do we have any participants from national level institutions, NITs, IITs, Triple ITs? Okay. So I understand the rest of us are working in affiliated universities, institutions affiliated to universities. Some of the institutions may be autonomous. Right. So with that understanding, we shall continue with our presentation. Okay. So cloud computing in education. Today, we are not just talking about cloud as online storage or shared drives. We are talking about cloud as the engineering backbone of modern intelligence. Here, this section is very specific to take an example of AI. How do we deal with that? Now, AI growth. AI is not just a mathematics problem. It is a fundamentally a systems engineering problem. Most of the algorithms powering today's AI were invented decades ago. What changed is not the maths, it is the infrastructure. Without modern cloud computing, those equations would be still in research paper. The hardware bottleneck. The hardware bottleneck is the math existed, but the machine did not. The machine was not. In 1998, Jan LeCun introduced LeNet5, a convolutional neural network used for handwritten digit recognition in the bank checks. It had roughly 60,000 parameters. It worked, but it could not scale to complex vision tasks like face or object recognition because CPUs could not process large matrix multiplications fast enough. But at present, the modern large language models like Gemini GPT, then other large language models are estimated to operate at hundreds of billions to over 1 trillion parameters trained across massive GPU clusters. The real difference is it is not the better math or algorithm. In 1990s, we trained models on single core CPUs, but today AI models are trained by clustering thousands of CPUs, such as NVIDIA A100 or H100 accelerators working in parallel. So in the cost-wise, in 1990, storing 1 gigabytes of data cost roughly no $9,000. But today storing 1 gigabyte in cloud object storage, that is AWS, is only $3. That costs around about dollar 0.022 cents. So we did not suddenly get smarter, but the computing became cheaper, faster, and massively parallel. Why AI requires cloud? Why I have taken AI? That is well known to everyone. I understand we have one participant from automobile engineering, but whatever may be the stream of engineering or any other course or any discipline that you are in, AI has its own role there. So AI workloads are bursty and infrastructure incentive by design. The training and advanced AI model may require thousands of GPUs running continuously for weeks or months. Once training is complete, you may only need a handful of machines for inference. So you cannot buy a 10,000 GPUs for a 3-month project. That would bankrupt any university or company. This is exactly why cloud exists. That is elasticity. You can rent a massive compute temporarily, then scale back to a nearly zero. So the economy part is a modern AI is not downloaded and run locally. It consumed via REST APIs. When someone uses ChatGPT or Gemini or other things, their laptop is not doing the computation. The inference happens inside a cloud data center, and the result is written over the network. When we take the AI versus Moore's law, traditional Moore's law predicted compute power doubling roughly every 3 years. Since 2012, AI compute usage has doubled approximately every 3 to 4 months. The standard enterprise structure cannot keep this pace. Only high-scale cloud performance can do that. So global cloud consumption trends. So money follows infrastructure demand, and AI is driving that demand. The global cloud infrastructure spending grew over 20% year on year, driven primarily by generative AI workloads. Gartner forecasts that worldwide spending on generative AI will reach around 700 billion in 2026 or beyond. The traditional data center, the racks, consume 5 to 10 kilowatts of power. The modern AI server racks consume 40 kilowatts or more. So this creates heat and cooling that challenges that most private data centers simply cannot handle it. The shift is the organizations are moving away from premise or on-campus data centers because AI hardware density exceeds their power and cooling limits. So only hyperscale cloud providers are engineered to operate at this level. So before going to the next session, let us have some discussion again. Okay. From the student perspective, let us see, or let us discuss Um, oh, now we say IT is sinking and the opportunities are shrinking. Now the students joining in the IT or CSC, then no, relevant branches are enormous in the market now, but yet to get placed. What could be the reason? Please share it in your chat window. So in the next section, we are going to deal with that. So I need to get your understanding and I shall take some input from you so that we can discuss further on it. Or what is lacking in our students? Or are they now industry ready? Because we are the same teachers, we are deploying the same courses, curriculum. They are getting better marks now because and entire thing is available with them. So they are learning with a great ease, scoring marks. They are now cracking the competitive exams, but they are yet to be placed or they have to find some jobs. What is a gap? Or how do we prepare them? Because our main purpose of existence in the campus is to ensure the students' growth. I shall like to get your perspective or actions on it. Can you please share? So we have faculty members. If you want, you can unmute and talk. What is lacking? What is really lacking? Any idea? Am I audible? Am I connected with you?
Yes, ma'am.
Okay, thank you. AI encroaching most of man-made works. So that is why CSE is booming or it is sinking. I think it is a madman efforts. Okay. No, AI is everybody's talking AI. We'll take blockchain, we'll take trusted systems, any advanced technologies that we have. That does not stick only to AI. So AI has some, that will be some controversy. Let us not focus on that. What is really lacking with our system, education system? The key pointer is if I develop something or if I run my code or if I develop something, it works for me. It will work in my machine, but it will not work everywhere. That is the gap. That is what lacking. So we have to first equip ourselves and then train our students. So whatever we do, it should be work. It should work everywhere. Let us start using cloud. Once we accept that cloud is infrastructure, the next question becomes very practical. what jobs are our students actually going into? The industry did not just rename roles. The cloud computing changed what engineering work looks like on daily basis. In the past, the teams were divided cleanly. The system administrators managed servers. Then the developers wrote code. Then the data scientists trained models. In cloud era, these boundaries were collapsed. The traditional roles, but still relevant, but expanded. We had system administrator, network engineer, backend developer, front-end developer. These roles still exist, but today they are expected to automate, scale, and design for failure. The cloud native roles are they design systems for highly availability, is a, then disaster recovery from day one. This includes multi-zone deployments, automated failover, and recovery objectives. So DevOps engineers and owns the delivery pipeline from source code to production. He manages CI and CD, that is continuous integration and continuous development, containers, infrastructure automation, and system reliability. Then MLOps engineer sits at the intersection of data science and DevOps, responsible for deploying models, monitoring drift, managing training pipelines, and scaling inferences. So we are no longer training students for isolated jobs. So we have to train them for systems ownership. The placement opportunities and market demand. Hiring is based on deployment ability, not just coding ability. When companies interview graduates today, they don't ask only, can you write code? They ask, can you deploy this reliably? So there's a high demand skill areas. Infrastructure as code. Tools like Terraform and Ansible allow engineers to define servers, networks, and permissions using the code. This eliminates manual configuration and ensures reproducibility. If infrastructure cannot be created from code, then it is not production ready. Then containerization or orchestration, Docker packages applications with their dependencies. Kubernetes automates deployments, scaling, and recovery. So this is now standard production, not an advanced specialization. The serverless computing. No, I do not want to repeat the same thing. Just we'll get into the industry what they say. So when it works on my machine, it's no longer acceptable because production is no longer your machine. Over 90% of organizations now use containers in production, and automated CI/CD pipelines are the norm rather than the exceptions now. Real world value generation. The cloud skills translate directly into speed, scale, and cost efficiency. This slide answers the unspoken answers from the management. Why should we invest in this? Right? So it's a scalability. Cloud systems are designed to serve one user to 1 million users using the same code base. Auto scaling groups add or remove compute automatically based on demand. This is not a feature. It is the default expectation in modern systems. So what is a speed to market? The provisioning infrastructure used to take weeks or months due to the procurement and setup. In the cloud, the same environment can be created in minutes using APIs. This fundamentally changes how fast innovation can happen. Then how do we optimize the cost? The traditional IT requires CapEx, the large upfront hardware purchases. Cloud operates on OpEx, pay only for what you use. So this lowers entry barriers for setups, research teams, and educational institutions. Cloud engineering is not about tools. It is about delivering val- delivering value faster at scale and with less risk. Okay. Now let us get into the cloud architecture in the campus. Okay, so I shall invite your input on this. What is your understanding or expectation or perspective in automating um, the campus? Hello, can you respond in a chat window or you can unmute and talk?
Ma'am, you mean to say that office automation like leave particulars or the students' information systems also some of the colleges they're using. That is
Yes, sir.
attendance
Yes, sir.
point of
Right,
view
sir.
and
Right,
subject
right,
is.
right. Yes, that is LMS, the learning management system. It is on cloud, on ERP. Yes, sir. Then, and obviously, almost all the institutions, they are, being
Because
converted to.
nowadays college also procuring action. That is a material management one side. Then
Yes,
the
sir.
man management and finance management, everything in see the college itself or university itself. So everything is computerized. That if you want to remove or don't want to invest money on the hardware side, you can make use of clouds. So
Exactly.
whatever you are doing, that can be implemented by using cloud computing. That's it.
Yes, sir. Yes, sir. Now, what I say, so we have highly invested laboratories in our campus. Now, there are certain workstations, i7 machines, GPU machines. Are we utilize them effectively? Whether the investments are converted into profits?
Yeah. That is to be audited every now and then frequently. If it is not utilized properly, then we have to replace that system with some other alternative way. See,
So,
nowadays all smart systems used, smart classroom, then smart library, something like that. So that type of things we have to go on or move
yes, sir.
on.
Yes, sir. I agree upon with you. For the LMS and the teaching learning process, mainly we use all now cloud services. But now with respect to infrastructure that we have invested on, whether we are utilizing it effectively. Now there are mostly they are underutilized. Still, we are running the toy problems, both in the regular practicals and projects, and unfortunately in research as well, because we don't utilize them. So in that case, instead of further invest, as you rightly said, first thing is we have to put all the infrastructure into a centralized thing, put it on, purchase a cloud space, share these resources, and whoever wants, need it, we can provide the services to them. So we can make money out of it, or we can make profit out of it. Then second thing is, so instead of investing further for taking up high-end researches, investing on the hardware, because these hardware after 5 to 10 years it will become totally obsolete and you cannot make anything out of it. But you can with the invest a little on cloud. You can use it with a you can utilize it, and you can for all our purposes. So this is the main
Sorry, I
point.
just like to interrupt you, ma'am. And though it is a new system and not going about an absolute system, the same lab might be used by many courses or many faculties. Each faculty will install their own system. Say Java, they will install one teacher, and Python they install another teacher. The same system will be bearing all operating system. Finally, we will not make use of these systems optimistically. Sometimes it will not work to any of the faculties. That sort of problem is arising.
I understand, sir, but that is only for 8 hours or 9 hours in a day.
No, ma'am, because of that, the system itself not working.
Okay.
It's a confused state. Yeah.
Okay, that is that is a different aspect of it. I'm telling we have the infrastructure, but whether we can, are you ensuring it is utility? Because we have well equipped infrastructure with us, it is completely working, whether we are utilizing it 100% or not. And if for any further need comes in, instead of investing further on it, we'll go for low cost investments on cloud. So with this understanding, let us move on to the next session. So let us move from industry into our own environment, that is university campus. I'm not going to detail on much on this because almost all the campuses are using this ERP LMS system. And the campus ERP system works fine 95% of the year. The real test is exam ready day. The real test is exam ready. So this we can really encounter this problem in even the university when the students or all of us are registering on the exam day. When the massive load is put on the system, now how that is responding to it. So that is no problem with this. So when tens of thousands of students log in at the same time, the cloud architecture is about designing for that 5% peak time without wasting money the remaining 95% of the year. So mainly the core architecture has present. I'm not getting into the ERP system, but I'm taking the architecture of ERP system, the presentation layer, application layer, and database layer. So here in the presentation layer, we have the static content, HTML, CSS, JavaScript, then all the front-end contents, notices, PDF is served through Content Delivery Network, CDN. The CDN catches content closer to user, reducing latency and protecting backend servers from the traffic spikes. This means the application servers are not wasting CPU cycles serving static files. The application layer, in the application layer, the ERP application runs on a pool of virtual machines behind a load balancer. When the traffic increases, the auto scaling launches new instances automatically. when traffic drops, the excess instances are terminated. On a result day, the capacity scales up automatically. At midnight, it scales down, back down. So there is a dynamic scaling up and scaling down. Then the database layer, the database runs on a managed cloud database service with automated backups, point in time recovery, and read replicas for reporting and dashboards. This removes the single biggest operational risk, that is a manual database management. So here we don't build for average load. We build for peak load and let the cloud absorb the shock. Again, this is virtual labs, that is virtual development interface and DAS, desktop as a service. Again, we are well aware of it. I'm not going to do much on that. The high-end lab hardware is expensive to buy, maintain, and refresh. Every institution faces the same problem. The GPU-based labs are expensive and they become obsolete every 3 to 4 years. Actually, I was little optimistic to say earlier that 10 to 5 years, but it is only 3 to 4 years only. And the cloud flips this problem. Instead of buying machines, we stream machines. Applications like AutoCAD, SolidWorks, Unity, or simulation tools require high CPU, GPU, large memory, and frequent upgrades. Most students do not own laptops capable of running them smoothly. The cloud solution for DAS is we have Mini, Amazon Upstream 2.0, Azure Virtual Desktop. So this means 30,000 laptop can access 3 lakh workstation at a time. Implementations inside us, the pre-built lab image ons, the scale desktops during the lab hours, shut them down during after the hours. Virtual labs turn hardware lacking or unavailability into scaling problem, and scaling is what cloud does its best. The research infrastructure. The research compute is bursty. The cloud matches that pattern perfectly. The research workloads does not need constant superpower computing power. They need short bursts of massive compute, often right before the deadlines. Buying hardware for peak research demand is financially inefficient. The cloud providers offer spot instances which use unused capacity at discounts of up to 90%. These ideals for batch processing, these are the ideals for batch processing simulations, training models with checkpoints. The trade-off is interruption, but research workloads are designed to cover it. So when we take the big data, Amazon EMR, that is Elastic MapReduce, runs distributed frameworks like Apache Spark for large-scale data pre-processing and processing. Clusters can be created in minutes and terminated when work is done. Databricks provides a unified and uniform platform for data engineering, analytics, and machine learning. widely used in academic and industry research. Then the storage life cycle management deals with the active research data which stays in hot storage, that is live storage. Completed or infrequently accessed data is moved automatically to cold or active status. This reduces storage cost without deleting valuable research outputs. The cloud allows university to rent a supercomputer for a week instead of buying one for 10 years. So this is the tools and ecosystem. So this is in this section. So what are the we tend to explore what are the different tools, and these tools are already being discussed in the previous sections as well. So I'll just go fastly in this section. So one of the biggest hidden problems in technical education is not the syllabus. It is the environment setup. The students spend weeks installing software, fixing dependency issues, and debugging configuration problems before they write a single line of meaningful code. Cloud-based developer tools eliminate this friction completely. And we know all the Google Colab, then GitHub code spaces. So what is now the bottleneck with Google Colab? So that can be taken care in the GitHub code space. Then here, this solves the classical classroom problem. When we start using those cloud spaces, so the student tend to say it works on my system, but not on yours. He cannot say that, right? So it has the educational impact. Zero installation time, no OS compatibility issues, then faster transition from theory to practice. When the environment disappeared as a problem, then the learning accelerates. And the well-known environment for us is a learning management system. So the platform that we use is Google Classroom, Canvas, Moodle Cloud. The teaching at scale requires systems, not spreadsheets. As class sizes grow, the teaching becomes more blended. The manual tracking simply does not scale. The modern LMS platforms act as the operating system of education. So here again, we use the integration of SSO or through then analytical tools for the warehouse BigQuery to analyze the student performances. Those are the well-known or standard LMS that we use. Once the learning is digital, then it becomes measurable. So the technical tool showcase. So I have taken the broader classification of academic domain. The different departments have different needs, but the cloud pattern remains the same. The browser-based access, scalable backends, and zero local setup. The computer science, we use Docker Hub, Firebase. The students learn how real applications are built and deployed today. And the electronics mechanical, they'll normally use MATLAB, SimScale. These systems or services remove the dependency on physical labs for many simulation heavy courses. The biotechnology life sciences, So they'll use AlphaFold via Collab. It's accessible through cloud notebooks, enables protein structure prediction without owning GPU hardware. The advanced research grade tools are now accessible even at the undergraduate level. Let us be aware of it. These are not optional add-ons. These tools are the modern laboratory. Okay, before getting into the next section, our curriculum design, I wish the participants' attention here. Whether is there any requirement or need to revisit or revamp or restructure our curriculum? If so, and which as aspect of it? Share your experiences, perspective on thoughts. As a current curriculum, is that okay? Is good enough to make our students industry ready? Or should we make any upgradations? If at all we upgrade, and what are the things that we can do that? Please share your thoughts. Okay, let me ask like this. We have computer networks, operating system, other core subjects. Do we have cloud computing as a core subject? Is an inevitable course for every student to learn? Please respond if you have that in your curriculum. Instead of an optional course, do we have a cloud or cloud-based courses as a regular or courses for all the students? Any faculty member in this forum can respond to this. Yes, we have in our syllabus, these are subjects are the core subjects. Or do we have any labs, cloud-based or cloud-equipped? Let us not say that, no, we have the drives, so we store the programs, not able to view your so comment. Not able to view yours, so comment. So I didn't get. What you're not able to view? Oh, no comment. Okay. Okay. Thank you for responding, sir. At least get, even if it is something, no, also good answer. So that will break the waiting state. Thank you, sir. So here, how do we migrate, or how do we transform our or restructure our curriculum cloud equipped so that our students will become industry ready? Cloud is the key pointer. It is not the optional. Let us now get into it. the next session, let us now discuss on this. At this point, the question is no longer whether cloud should be taught. The real question is how seriously it should be taught. To answer that, we look at what technical institutions are already doing. Let us not take no, the universities in abroad. So already they have revamped their structures. But our premier institutions in our nations, like IIT Bombay and IIT Delhi, so I'll be sharing this now presentation with you. So we have the syllabus link. So whenever you get an opportunity, if you're autonomous or if you have anything to the university to suggestions that you can do to your university, so you can look at these syllabuses and suggest the university to include such kind of courses as a core subjects. The IIT Bombay, the course, the pure operating system is being converted into virtualization and cloud computing. Can we believe that? So they teach how to build a cloud rather than how to use it. So for which they have framed the syllabus. So the students learn how hypervisors, containers, then cloud abstractions actually work, how to build a cloud, not just use one. In IIT Delhi, they introduced a subject, cloud computing technology fundamentals, through which they introduce cloud computing, data center design, software defined networks SDN, and data center designs. IIT Madras, cloud and distributed systems are integrated directly into degree programs, especially with BS in data science. We all know well that IIT Madras is offering a bachelor program online in data science, where cloud native and distributed data processing are treated as foundational skills. The insight here is when IITs teach Kubernetes and virtualization and SDN as core system knowledge, we cannot restrict ourselves to the definitions of SAS and PAS. So here the regulatory mandates, AICT and UCG alignment. The cloud computing is no longer optional. It is explicitly encouraged by regulators. Sorry. There is often a concern that adding cloud courses may conflict with regulatory frameworks. In reality, the opposite is true. The ICT explicitly lists distributed and cloud systems as a recommended as a micro specialization. Some universities, they say minor course with 18 credits. Yes, it is clearly signaling that cloud and distributed systems are employability critical skills. The UCG guidelines provide frameworks for programs like BCA, MCA, which emphasize open electives in emerging technologies, explicitly introducing cloud computing. So institutions are encouraged to offer flexible, skill-oriented electives aligned with industry demand. So teaching cloud is not a deviation from policy. It is a direct response to it. So here is a proposed course curriculum. So there are 4 units. The first unit, the virtualization layer, cloud architecture, then the cloud native and DevOps, data and AI on cloud. Then how do we deal with the technical topics and practical outputs are listed out and on the proposed curriculum. So we can take this, the reference is also being given. So when I share this presentation, I wish all of you to explore these details further through these links shared. So build a serverless function triggered by file uploads to cloud storage. So when we teach file operations, let us teach how do we run file operations on cloud. Then a lab implementation strategy, zero cost to low cost model. The biggest misconception is that the cloud education is expensive. In practice, public cloud education programs make it cheaper than physical labs. So we have certain free trials for, especially for students. Say AWS Academy, it provides structured curricula and free learner labs, typically with $100 cloud credits per student, so without requiring credit cards. Then Google Cloud Skill Boost offers ready-made. So I think most of the institutions are having Google Developers Clubs through which the cloud certifications are offered. Please encourage our students to take up those certifications seriously. This now Google Cloud offers ready-made cloud labs that runs on real cloud infrastructure. Students learn by doing, not by simulation. Then GitHub Student Developer Pack. The students are free to access cloud credits, Azure and DigitalOcean, then developer tools and platforms. Do not attempt to build a local private cloud unless you have a dedicated system team to take care of it. Use public cloud free tiers for teaching. Then assessment model. We must assess engineering ability, not memorization. Traditional exams test recall. No, so exams only the memorization or recall. The cloud engineering must test execution. So in the midterm assessments, we can have architecture diagrams with respect to scenarios being taken. All fundamentals can be taken. But we can have two assessments, midterm assessment on the concept level, then end-term assessment on the deployment level. The students are given work code and asked to do it, deploy it, scale it, expose it via public endpoints. It's happening in premier institutions. That is why the students are now, the industries are waiting at their gate for their students. No marks for writing codes that never runs. Why this works? The project-based assessment aligns with industry hiring practices, real-world engineering workflows, outcome-based educational models. When students graduate, they should be able to ship, not to just explain. So here, now one example question that we can ask: don't write the code. Here is a Python script. Deploy it on a load balanced auto scaling group and show me the URL working. So another deployment challenge that we can give us, suggest a final exam format where a student must deploy a live URL. If the URL works on your phone, they'll pass. If it crashes, again they'll debug, they'll make it work. They should make it work. This mimics the real industry pressure on them. Okay. So before getting into the next session, let us discuss what are the challenges now transforming our campus, upgrading our curriculum into a cloud arena. What are the challenges that we can encounter? So could you please share your thoughts, experiences? Sorry, sir, Kumarasamy sir, I'm just seeing your comment. Elective subject is based on national interest and for national deployment purpose. Yes, sir, we have open electives. The students are uh, encouraged to take open elective of their choice. But there are certain courses we have to make them as mandatory, irregular courses. So that is what we discussed. Now let us get into the aspect of challenges. So any challenge that we can encounter if we go for it. Can you?
Ma'am, slide is not changed. It is assessment model is a display.
Yes, sir. Next slide, I'm keeping it waiting. We'll discuss and I'll move on to the next slide. You want to convert. So for example, if you want to conduct a cloud-based lab, what are the challenges that we can expect? Any thoughts? Let me ask this. The faculty member uh, conducting a lab course on cloud. I'm asking about cloud programming or cloud computing. Normally, we don't touch upon cloud computing, though we teach cloud computing. We'll focus more on its architecture level discussions. Actually, cloud computing is much easier than our application development coding. It as a cloud, no, we all know well that no, it is an infrastructure. So we are given with certain resources. So these resource and privileges. So we have to identify the resources with some, you know, identification numbers or the key terms. So they look little complex. They only look little complex, but dealing is so simple. Like if you take a machine coding, if you use all the port IDs, they'll learn as Outlook, it looks so complex, we cannot deal with that. It is so simple because not much logic in it. Now we need to use the resources. Then as per the policies, we have to compute the policies. So whenever we use it, uh, when after our completion, we revamp, no, we close it, store it, then we lock it, will come out. No, so these are simple things before we start and after we do it. Cloud computing is much, much simpler. Only thing is we need to know how to use the resources with its configuration and doing, you know, programming or computing on cloud is safer. But if you have to make a system configuration efficiently, if you make it, then you can keep everything safer on the cloud. So with this understanding, let us move on to the next session of the uh, presentation. So here, the challenge that we have is at this stage, the idea of moving labs and systems to the cloud sounds exciting, but we must be honest, there are real implementation challenges. The good news is these are all not academic problems, these are engineering problems. And the cloud ecosystem already has standard solutions. Certain challenges we have: bandwidth, budgeting, and security. So in the bandwidth, if our network is weak, the cloud labs won't fail slowly. That most of us might have encountered it or experienced it. They will fail loudly. They will not, their failure is not subtle. They fail loudly in front of the students. On a particular day, when we start any international programs or national level challenge, we can and experience such bottlenecks. But here that depends upon I'm not talking about the internet. Internet, we need to have sufficient bandwidth. But when we on cloud, if you don't do good load balancing, then we have to face its challenge. Then budget, this is not optional. It is not a question of whether you can live with the electricity or not. We are living with electricity. How much you are going to use it, so that is a question. Or it again is a personal choice. I prefer to live with that electricity, that I prefer to have such a lifestyle. Go for it. But here it is not an optional, because and it is not optional for the BOS. It is not optional for the institution, or it is not optional for the faculty. It is because we have to ensure our students' growth. We do not have options. The budget alarms are the seatbelts of cloud adoptions. So we have to make it tight, ride it faster. Then security, the faculty and the student must understand shared responsibility model. The cloud provider secures the cloud, that is data centers, physical infrastructure. We secure what we put in the cloud. It's like we have the locker in banks, the accounts, permissions, data configurations. The cloud is not insecure. The misconfiguration is insecure. How much you take care of your personal locker, to whom you share it, how much protection, how you keep the data, no, your valuables, how do you take it out, how safely you take it out, use it, how safely you keep it back. So in that pathway, you have to take care of it. Then the summary, and we'll call to action. Let me end this with a practical call to action, because cloud education only matters when we change what we do in our classrooms. So we have this high responsibility. We don't need a full curriculum overall to begin. We need one concrete step in the next semester. What is faculty goal, student goal, institution goal? The faculty goal is to move one assignment or lab into cloud this semester. It could be a collab notebook, already we are experiencing it. Then a code space based lab or small deployment task. That is a gap that we have. It must be real one. The student goal is obtain one foundational cloud certification. This creates a measurable employability signal and forces the students to learn cloud vocabulary the industry expects. The institutional goal is to integrate cloud architecture concepts into the syllabus review and the infrastructure. It is not just not ask what is SaaS and PaaS, but VPS, IAM, containers, CI/CDs, and deployment thinking. If you do these things, cloud stops being a topic and becomes a capability. Thank you all. So with this, I close my presentation. We have a few minutes for discussion.
Dear participants, if you have any query, you can post it in the chat box or you can unmute and ask it directly to the resource person.
Please excuse me for 2 minutes. Let me take a sip of water. Some of the key pointers that we discuss here are yet to be experienced in our campus as well. So this study would explore and give us some directions in this direction.
So I hope there is no more queries on this particular topic. Thank you, ma'am, for delivering such an informative session. It was highly insightful and beneficial. Thank you so much, ma'am.
Yeah, thank you. And thank you all for tolerating my voice and my presentation. Thank you. Thank you so much.
Dear participants, the feedback link is posted in your WhatsApp group. The link will be active for the next 30 minutes. Kindly fill in. Thank you so much. See you all tomorrow at 6 o'clock, 6 p.m. Thank you.